We are a community of DevOps and security professionals who are passionate about developer and team productivity. Through our network, we promote DevOps and security practices for product engineering as an efficient method to keep pace with constantly shifting demands. Need of market is to have shorter, more frequent delivery cycles for software solutions that are secure and reliable. Our network promotes growth of members through of DevOps professionals through mentoring, job opportunities, and collaborative learning to stay ahead.
Hello, good morning, good afternoon, good evening to all ever who have joined in. So let's start the session. So today's session, which is the uh, third part of our webinar, uh, is for the packing your code in containers. So today we will talk about how we can leverage Dockers for productivity and performance. Right. So let's start. So, what is the Docker? What, why, how? These are the basic questions around the Dockers, which everybody talks about these days. Correct. Uh, this is very important buzzword, or everybody talks about Docker, Dockerization, containerization, but what it is. Correct. So, in this session, this webinar, we will talk about what is a Docker, what is a containerization, how it is different from the traditional deployments or the traditional way of running the applications. What are the advantages? How does it make things or life of developers and deployers easier? How does it helps in deploying the artifacts or binaries easier, maintainable, and we will also see how and where does it fits into the DevOps pipeline. So let's start with this picture. Uh, if we just talk about a native or naive terms, then Docker is nothing but it's just a software, computer software used for virtualization in order to have a multiple operating systems running on the same host. So if we see this picture, so normally we have an operating system, and on the top of operating systems we have the binaries and libraries, and then we get the executable or executable environment to execute our uh, applications. So that is the very old traditional way. We have a computer, or we are running a virtual machine without a hypervisor. So then next comes the uh, like earlier we used to have a racks of systems where you used to have an operating system, and then depending upon what kind of a software you want, like for example Java, PHP, those were installed, and there we were running the our applications. That was a very traditional way of doing or deploying the or running the applications. Then there came the concept of virtual machines. So virtual machine is uh, so you have a basic infrastructure, which is basically cores, RAMs, and network devices. Then on the top of that, you have a hypervisor. Right? So what does this hypervisor does? It provides the executable environment where you can basically install your OS, correct? And on the top of OS, then you can install your binaries, libraries, and your applications. But this hypervisor, what it does, it schedules these different operating systems. So if we say, if we just take a very simple example, so what we used to do, we used to have a uh, virtual machines, in terms of Oracle's virtual machine is there, correct? So there, what happens, we have a Windows machine, but using the Oracle virtual machine, which is a hypervisor. So there are different categories of hypervisor, hypervisor 1, 2, 3. So it is a hypervisor which basically abstracts the lower operating system, which is basically a host operating system, from the guest operating system. So what you can do, you can execute a Ubuntu OS, you can run a Ubuntu OS on the top of Windows machine using the software level or software type hypervisor. Similarly, there are certain hypervisors which runs on the top of a infrastructure, bare metal hardware. So there you can have a different virtual machine. So each type of hypervisor have their own advantages and disadvantages. So this is was the one of the uh, deployment or way of running the application. So in this way, like you can have a very big hardware, then you can execute multiple guest OS, and depending upon the need, like you can have a Windows machine, Windows OS, Ubuntu OS, or like Mac OS on a same machine running using the with the help of hypervisor. Okay, so what is the problem in this case is, like these virtual machines, they are very heavy, though they provide you flexibility of running multiple OSs on a same machine, but still they are very heavy because you have to run the complete OS, then application and those kind of things. Correct. And obviously scheduling by hypervisor, and then again you have a scheduling at the OS level. So in this way, these becomes very heavy. Then there came a concept of containerization. So Docker is nothing but it provides a functionality of containerization. So in many of the cases, what happens, like uh, OS, like most of the applications, they are like they don't care about what is the OS down the uh, infrastructure, correct? So you just concerned about running your application, and you have a set of binaries. So that is the only need. So like if you just want to run a Tomcat, for example, so you don't worry about what is a OS. You are concerned more about what would be the, like environment for running my Tomcat. Is it a Windows? Is it a Linux? Is it a Mac? Correct. Then you need to set some environment variables and those kind of things. So here what happens, like Docker runs on the top of host operating system. This helps you to improve the efficiency, because now you don't have to deal about, like operating system being scheduled, correct? So it's a complete OS, and on the top of that, it is providing you a environment where you have a complete isolated uh, container, correct? Any settings which are done in a container A will not impact container B. So they are all isolated uh, containers or environments. Okay. So this was just starting. Let's go more deeper into this concept. So what are the different use cases of Docker? So uh, there are multiple ways of looking into it, but this is one of the picture which like divides the functionality of the Dockers based upon these 8 points. One is the app isolation. So we just talked about, like containers or Docker basically provides you an environment which is isolated. So any configuration change or any environment variable getting changed, or if you install a one uh, software or inside, that will not impact the environment in other uh, container. So that is the app isolation. Then there is the debugging capability. So what does it the uh, just So app isolation, as we just talked, so it's basically, or just to give you another example, like if you want to have a Jenkins running along with the, for example, GitHub. So, or sorry, GitLab. So GitLab provides two kind of licenses, which is one is the enterprise, and other is the customer uh, community version. So community version you can install on your local network and then use it. So this is very useful when you don't want to expose your code to the public. You just want to keep it inside your network. So in that case, what we can have a single machine, correct? And then we can install the Docker, and then we can create two containers. One container with Jenkins, which might be running like on the using the Ubuntu. So there you may have a different requirements for Java. For example, you want to have a JDK 1. Say 8, correct? And for GitLab, if you have the requirement of JDK 1.11, JDK 11, for example. So in that case, this can be easily achieved using the Docker. So you can have different set of configurations for different Docker, of different containers. So that is one of the example. Uh, then there is also, like if you go to the debugging capabilities. So Docker provides many tools that are not necessarily specific to containers, but they work well with the concept of containers, such that you can create checkpoints, you can create versions for container, as well as like to different to containers, which is immensely useful in mixing an application. So then you also have a, like attach like console to the container, so that you can check what are the logs inside each and every container. Then another part is the rapid deployment. So Docker containers can be created and up in milliseconds. So this is achieved by containers by not booting up an OS. So if we see, like if we see the traditional way, if we just go back to our previous, just if we just go to this figure here, so if you see here, so if you have to create a new VM, so it is a very like it takes a long time. So if you have to shut down, or if you have to create a new VM, it will take a long time. So you have to, like if we just talk about restarting, so it would be like you have to shut down the whole guest OS. It will shut down, it will come up, it will start its services, and only then your application will start. So that takes in some of the cases it may take up to minutes, 5 minutes, 10 minutes, 15 minutes, depending upon how many application and services are running. But with the container, it is very simple. So it's just a matter of few seconds. Container can be created. Containers can be, you can start them, you can stop them, and if you want, you can destroy them. So that helps very much in rapid deployment. Correct. Then, if we talk about the simplifying the configuration, which is the this top, sorry, which is this top point, which helps you, like in Docker lets you put the configuration file into the code, as well as via the environment variables for different environments, and deploy it. Hence, the same Docker image can be used for different environments. So, if you just give you an example. So if you, so Docker provides you functionality where you can pass the configuration, correct, as a part of Docker file itself. We will just talk about what is a Docker file, or you can pass these configuration from the outside. So if you have a, Docker image, you can run it for Windows, you can run it for Linux, or you can pass different configuration from the outside. So whenever you are starting it up, so you can provide different configuration. So same container, can be used with different configurations, which is not possible with the traditional way of deployment. Like if we go with a virtual machine, so they are like you cannot pass any configuration from the outside either. You know you have to create a new virtual machine, correct, uh, uh, or otherwise it is more kind of a closed box in terms of configuration. So then we talk about this developer productivity. So in development environment, basically we need to achieve two major goals. One is we want development environment to be as close as possible to the production, uh, and secondly we want development environment to be as fast as for interactive use. So what happens, like sometimes you might have heard like this code works on my machine, correct, but once that build is given to testing team, so that stops working. So that is a biggest challenge currently many organizations or many development teams they face, because the developers environment that is different, correct, and whatever is there on the production environment, that is different. So some people they might have done some configuration on their local machine, correct, and they just forgot to mention it in the release notes, or some they download some binaries and they just forgot to update it into the form.xml, which is basically a Maven uh, configuration file. So same thing doesn't work on the production. So this Docker helps in first part. So you can have a same environment in the developers machine, or development environment, which would be like similar or close to what the production environment. And another one is uh, you might have heard from many developers, like I have to set up my deployment environment, which will take 1 day, 2 day, 4 hours, 5 hours, because installing the softwares, talking to IT teams, getting it installed, if you don't have admin rights, then you have to have the correct version of software. Like if you're using a JDK, then you need to have a correct version, otherwise some of the things might not work as expected. So that is a biggest challenge which Docker can solve. So you can have a Docker container which is pre-built, or like you can have a Docker file which has all these things, and they just need to build the container. Or if you already have a container, you just need to uh, run your Docker image. So that is just like makes a life simpler for developers as well as for whole project, because that deployment environment would be close to production and it would be ready in shortest span of time. So we will just see how we can do that also. Then another point is the server consolidation. So server consolidation of Dockers allows consolidating multiple servers to save on cost without the memory footprints of the multiple OS, and the ability to share the unused memory across the instances. Docker provides far denser server consolidation as compared to VM. So let's go back to the this picture again. So if we see here, so here, once you are creating the virtual machines, like in traditional way, so what happens, like you need to think about uh, memories, like before you start creating VMs, you have to create a virtual machine with a configuration, like how many ports to be allocated, how much RAM to be allocated, how much memory, physical memory should be allocated, and if you allocate little less, then you have to restart everything. And some of the times, like here also tend to allocate buffer. Basically, if you want X amount, then we will provide, for example, 30 percent of X more, so that no your future needs they are also uh, addressed to some extent. So what makes this so major problem from with this X is like no, you are increasing the footprint of your uh, servers. So like in terms of OS as well as like memory and other resource requirement. But if you go with a container, so you don't have to like specify how many cores needed, how much RAM is needed. So it's all taken care by Docker itself. So Docker layer will manage everything. So in this way, like your footprints of your servers, they becomes very less, and you can host more containers as compared to if you go with a virtual machine approach. Okay, then we then the next part is the multi-tenancy. So one of the use case for Docker is using multi-tenancy application. So what happens like if you have an old application which basically is not meant for multi-tenancy, which is not uh, designed or written to support the multi-tenancy, so that also can be done using the Docker. So how we can do it, like if it's for example is to develop quickly and easy multi-tenancy for an IoT application, right? So code base for such multi-tenancy application are far more complicated, rigid, and difficult to handle. Re-architecting the application is not only the time consuming but also costs lots of money, because you already have an application which is running, which is time tested. So if you write something, so you have to redesign everything, you have to rewrite everything, you have to test everything. And even though testing still leaves some of the bugs there, so with the time only software matures. So you still have some hidden bugs which may come later from production. But with the Dockers, it is easy and inexpensive to create isolated environments for running multiple instances of the app tiers to each tenant. Correct. So for example, I just given an example. If we have an IoT application which does not support basically multi-tenancy, so you can only use it for customer A, correct? But customer B comes and says like I also want to use your application. So what will you do? So another one way is so we just discussed, which is not a good way, to re-architect or or to do some kind of a hacks and those kind of a things. Other is you just create a new Docker image, containerize that application, and configure it for customer B. Correct. You can have a different database for both the customers, and in that way, your application is ready for multi-tenancy. So that is one way of using the Docker images. Okay, then one part is what is left is rapid development. We have already seen, like creating the Docker or starting stopping Docker images is just a matter of seconds. These can be done in seconds and sometimes in milliseconds. Whereas booting up the OS takes a long time, and during that time your service will remain down and customers will be shouting because they will be just not able to access the services. Okay, so now let's come to the next topic, which is the uh, how we can use Dockers in our DevOps workflow. So since this webinar is for DevOps, so we will see how we can utilize the Dockers in DevOps workflow. So if we see right from the first box here, which is the local development environment, so you can use any uh, ID to write the code, and then you have some Docker tools, correct? And then obviously, like you have a source code and CI, which basically where you submit your code and your code is version. Then you have a CI/CD tool, which basically picks your code from source repository, compiles it, and uh, does the CI and basic quality checks. And then using the Docker's tools, you can create Docker images of your application. So we will see one of the example of what is a Docker image and how it is created. So we can create Docker images using the CI/CD pipeline. So there are multiple tools which are available, which you can install as a plugin into your CI tools, like for example Jenkins or any other CI/CD tool. Then you have a Docker Hub or Docker repository where you can store your images, your Docker images, or you can say Docker container images. So there you can store and create different versions of your Docker images, correct? And then based upon whether it's you want to test it in a test environment or you want to do it in pre-production or production, you can define your deployment target in obviously CI/CD pipeline. So it can be public cloud, it can be your on-premise data center or on-premise private cloud, or it can be your data centers, just machine with the Docker running on it. So this is the overall flow where your CI/CD pipeline can create Docker images based upon the deployment targets. These Docker images can be run, can be shut down, can be destroyed, can be recreated again, and you are ready to provide your service. So this is the basic DevOps workflow based on Docker services. Okay. So now we will discuss what is the Docker architecture. So if we talk about, then Docker is basically at this level we have a three boxes. One is a client. So it's basically a Docker client which uh, can do a multiple operation. It can build the Docker images. It can pull or push a Docker image from remote, which is in this case is the registry of Dockers. So we will just go through one of the registry, uh, and then this client basically runs these Docker images, it runs in a containerized environment. So it client can trigger these things, but actually these things happens on the Docker host. So for example, running a particular Docker image, you can tell Docker host will basically fix the images and create a different container, create the environment based upon whatever configuration you have created. It will create the configuration and run the containers. Then we have a registry. So registry can be used in two ways. So one registry is you have a different uh, Docker images, pre-built Docker images, which are available there, or you can push your custom or your created Docker images to the registry so that you can pull later for running on a Docker host. So obviously the communication between client, host, and REST is based upon REST APIs. So that is just a standard these days. Okay. Now coming, just talking little more about this Docker components. So if we see at the high level, so first component is the Docker engine. So it's basically Docker is a client server type of application, which means we have a clients who relate to the servers. So Docker daemon called Docker ERT is a Docker engine which represents the server. So basically, just we talked about in previous diagram. So we have the two parts. One is a client and server. So uh, server part, which is basically a daemon, uh, which we call server. So and clients can run on same machine or they can be on different machine also. So it's just like binary client binary which you can run, and it talks to the this daemon over the RESTful APIs. Okay. Then next component or term which we hear a lot is Docker images. Docker images are the source code for our containers. So we use them to build containers. So I will show you example how we can create Docker images. But for the time being, we can just say they can have a software pre-installed which speeds up the deployment. So normally what happens, like for example, if I just want to run a Jenkins server, so I will just take an example of Jenkins because it is more close to our DevOps topic. So what happens, like if you want to run a Jenkins, so there might be certain parameters which you would like to pre-configure, like port, for example, like instead of 8080, you want to have some other ports, for example 4 times 8, correct? Then you want to provide the uh, minimum Java heap or maximum Java heap size. Then you want to have some other configuration parameters like predefined plugins, for example, like pre-configured plugins. You want to have some other parameters which you want, like you don't want to configure again and again. So you can define those kind of parameters, environment variables, configuration, or even a version of Jenkins in a text file, correct? And then using that text files, you can create a Docker image. So once you have a Docker image, everything is now uh, clubbed together. So like everything is packed together in a image. So now you just need to run these Docker images. As soon as you run these Docker image, a container would be created with all whatever you have already imported as a part of this Docker image. So all the configuration will be available, like along with Jenkins. If you want to like have for example, if you're running a Jenkins inside a Tomcat, so you can configure that also. So everything would be there, and it's just matter of running it, and you can run that image uh, anywhere. Like you can distribute that image and say, like some other project. You can give them to same image and they can start running it. So they don't need to do any configuration or any other. So it's just a kind of a ready-made uh, or pre-configured software which is just need to start, and it will start working. Then another part is the registry. So Docker stores the images which we build in the registries. So it's basically uh, version control software or version control registry for the Dockers. So there are two types of registries, public and private. So some of the times, like your organization may have a mandate, like you cannot share or your registries, sorry, your images, because that contains sensitive data. So in that case, you will set up your private registry. Otherwise, there are public registries uh, which you can use. So there can also be another way, like you can pull pre-built Docker images from the public repository, and then you can customize and create your custom Docker image and store that privately. So next part is the Docker container. So Docker containers are the organizational units of Docker when we build an image and start. running it, we are running in a container. So basically, we say it's a container. It's nothing but just a isolated environment. So all the configurations of other containers you will not be able to see. Your container will not be able to see, and whatever configurations you do inside your container, that will not be visible to outside, like to other containers. So it's basically shippable software which can be modified, managed, created, or destroyed, and it itself contains everything. You don't need anything else when you need to start it. So we can say it's like image is a template, and container is a copy of that template, so which is created from that template. Okay, now we have done a lot of talking, so now it's time to do some hands-on. So let me just share my screen itself. So I already have some these links open. So so basically, Docker comes into two flavors. One is the community version, and another is the enterprise version. So enterprise version that comes with if you have some queries or some issues running it, then Docker has a technical team. They will come back to you and they will have some SLA. But that enterprise is a licensed one. But community version is sufficient. There's a lot of support in terms of community blogs or different uh, forums. So if you go, you just go and see. Hmm. So Docker is is available for different platforms. If you just see here, so you can download it Mac or Windows, and then you have it for different uh, Linux flavors in terms of DB or RPM or in different formats. So if we see for Windows, then this is here. You can download this Docker image. So I have already downloaded one version here. So if we see, this is a Docker installer. So it takes little time to install it. So we will just skip it. So correct. So one of the requirement for Docker is to enable hypervisor V, correct, and only then you will be able to run it. So you have to go into your boot and do the changes in BIOS, and then only you will be able to run it. So there are instructions available in this document itself. So you can just go through it. But enabling hypervisor in hardware is a very easy part. So you will find based upon what machine you are using. Okay, then next part is this is from where you can download your Docker engine, correct? So once you run the Docker image, this Docker software and start it, then you will see this kind of a uh, icon here. So it takes a little time to start. So until unless it is started, you have to wait. So there are different options. So you can connect to your repository. So it also provides support for Kubernetes, which is basically a Docker orchestration tool. So basically you can image the Docker containers using Kubernetes. So then you also have a dashboard. So it will tell you what different uh, images you have, or you can run it. So you can start a Docker image, you can restart it, you can stop it, and you can delete it. So if I just go back to here, so all these image operations which are possible on Docker, they can be done on using the GUI, because remembering commands is not easy. Sometimes we forget the syntax. So this is just a visualization tool of that thing. So we will just go through these commands once, and then get back to the what we want to do, uh, like basically the hands-on part. So there are certain commands like in Docker info, which gives you know information about your Docker. Then Docker pull, it is like you know if you want to pull an image from your repository, you can use it. Similarly, you have a Docker push if you want to push an image. Then this is Docker run. So if you have a Docker image, you can run that as a container. So you just need to give the image name, and then uh, just other small arguments. Some are optional, some are mandatory. So we will just go through each and every one. Uh, so you can also stop a container once you have set it running. You can stop it and then start it. Then using the Docker PS, you can get the list of all running containers. Uh, Correct. And then Docker images is a list of images which you have downloaded. So this is the like we will just go back to the things, and here we will see what is the core of a particular Docker. So we will see here we have a sample Docker uh, file here. So one important point is like Docker file has this name in this particular format, which is a Docker where D is capital and file is a file. If you don't follow this, then you will not be able to run your Docker. So we will just go through what are different things. So what first line is from Ubuntu. So if you're creating an Ubuntu image, so you have to provide this from where Ubuntu. So basically, this is the Docker image, pre-built Docker image which you want to use. So for example, if it is was a Jenkins, so if you want to create a Jenkins server and do some configuration parameters updates on top of that, there you can provide from Docker. So this is the public uh, Docker image for Ubuntu, correct? Then next part is, once we have an image, we would like to do the apt get update so that all the packages gets updated to the latest version. Then we would like to have Apache 2 installed, and then we would like to install the Apache 2 utils, the utilities required for Apache. Then we just want to do the cleanup, and we want to expose the port 8080. So now what happens once you create a container, correct? So your Apache basically might have some port which is basically 80, but once you are running a multiple containers, port 80 might be used by somebody else. So you want to do the port mapping. So here you can do the port mapping. So here you are exposing port 8080 outside the container, which is internally mapped to port 80. So this can also be done using the commands which we will see later. And this is like where you can pass on different arguments to the system. So basically here we are passing arguments to Apache using the ctl command, that we want to run this in the foreground. Similarly, you can pass different configuration parameters to your tools. Apache, for example, if you want to change the default port of an Apache, then you can pass corresponding. Basically, you can set the corresponding variable, and which will basically change the this thing. And similarly, if you want to do some others, you can run like run copy, or for example, if you just want to create an index file, you can create an index file, for example index.html. Or if you have something just to give you HTML. So it will create an HTML file, correct, and then can copy it into the Apache path, which is basically like CPY copy. Well, just don't go by the syntax. Syntax might be incorrect, but index.html to where uh, ww HTML. So these kind of things you can write in the Docker file. So you can customize your tool or your software uh, based upon whatever configuration you want. Okay. Otherwise, what it would have been like, you would have to install the Apache and then all these configurations. Like if you were to do same thing in the traditional VM based system. So this makes life very easy. Correct. Uh, so this is what I was telling. Like these are the different. This is one of the sample file. So it's very simple. Like you can provide maintainer and using the run command, you can provide whatever you want to do. Then there are different commands to build it. We will just come back like here like docker build minus t is like you want to provide a tag or like name to your docker image so that you can later use it. Then okay, so let's come back to the public repository. I will show you how a public repository looks like. So this is the Docker hub, which is a public one of the public repository. So you can configure it. You can pull any image. So for example, if I just want to use the engines, so I can pull a public image from here. So this is the command. I just need to run it on my local machine, and then it will pull the uh, engines container. So basically, if somebody asks you to run a Docker image of for Nginx, I don't want to run a complete Nginx tool, execute and then those kind of a thing. So here I can just pull the Nginx image to my local machine, so basically my Docker host, and then execute this Docker image as a container. So this is very interactive. So if you just want to go and see what is this, so if you see this whole Docker Hub provides different commands itself, so you don't have to remember everything. So this is like if you want to run it in a local machine, you can run it. So if you want to create a Docker file and then run it, if you want to do some kind of a configuration changes, so in that case you can also create Docker file. It provides you a sample code, right? So it's like I had a in this case like there was a static HTML directory, uh, right? So what I'm doing here, uh, it will download the Nginx uh, image from the public repository. Then it will copy this content from this file into the Nginx folder. So if you have ever worked on Nginx, then this is the one folder from where you can basically copy your contents, and your Nginx based web server will start. So you can configure code from your local machine, then package it into the Docker file, and then you can just run it, and then you will have a web service running with this code. So I was just about to show you one thing. Not able to find. So basically, I was trying to show uh, how they have created this Docker file. So basically this Nginx is also a Docker image. So they must have done something like from Ubuntu, and then they might have copied this Nginx software, and then they must have done the basic configuration, and then they created this Docker image as a Nginx, which we are further copying it and doing configuration. So they just keep on changing the different uh, sorry, I'm not able to find it. So but normally you can just go and search it further, so it will show you those parameters also. Mhm. Okay, so we will see, come back, otherwise uh, during our next sessions we can take it up. So this was like, how public uh, Docker images they are created. Okay, then this is one example where we, like, uh, downloaded a Ubuntu, and then on the top of that we installed Apache utils, and then uh, running this as a this. So once we run this command, docker run -d -p 8080 my web server, then, like, using the localhost :80, you will be able to access the default Apache page. Correct. Uh, so now coming back to example. So I will just take the example where I will just show you this folder. So I have already created one Docker file, uh, which will do, which will basically run the Jenkins for us. So it's very simple configuration file. So what it does, it will download Jenkins. This is the name and tag, and this is the version. Correct. It will pull the Jenkins image from the public repository and put a label. And we are not doing anything more than that. But though we can do many things, like, we can configure port and those kind of things we can provide. Like if we want to change the default port and other things we can provide. Just for the simplicity, we will not do anything. We will just do the same thing. Correct. So here we have. So uh, what I will do, I will, these are the set of commands which we will be running. So this command basically builds the Jenkins container, Jenkins image using the publicly available Jenkins image. Then I will name this Docker image as my Jenkins. Correct. So if I see, so now it is in the background pulling the Jenkins version 2.16 from the public repository. Correct. And putting the label, and then creating a new Jenkins, new Docker image with name my Jenkins. Since I have already done this step, so it took very less time. Otherwise, it would have taken 2-3 minutes, because it needs to download multiple things, like, whole Jenkins would get downloaded, and based upon your internet connectivity, that would take different much of time. So here, if you see, we should just try to decode it. Here it downloaded the uh, Docker's image, correct? It has put the label, and then build a new Docker image, correct? Then next part is how to run it. Now we have a Docker image. Now we want to run this Docker. We want to generate, or we want to create a container out of this Jenkins, Docker image. So if you see the format, it is Docker run, then -p is the port. So this is what I was trying to tell you. You can change the port mapping. One is the internal port, and one is the uh, output port. So 8080, first one is the exposed port, what container will expose outside, and these are the internal. So basically, like, if you want to change, you can change it to, like, internally Jenkins is running on 8080, but outside, if I want to access, then I can access using the 4 times 8. So just to keep it simple. Then I will name the container as my Jenkins master. This is the name which is for the container, and here I am providing the name of my uh, Docker image. So, if, for example, if I had 5 6 different Docker images, I know then this name would have changed. So now just run it. So it takes little. So this is the now here I am installing and running Jenkins, and it is taking very less time. Though my machine has some other things running, so it took little more time. So now it says like it is already running. So I just had it running. So I will just try to, uh, okay, it is stopped. Let's remove this Docker basically container. Okay, now let's start on it again. So these are the very basic commands like stop, start, remove, for the managing the life cycle of a Docker. So if I see, it is taking little time because of less RAM on my system. But if you run these commands on actual production environment, so it would take just matter of seconds. So if I just go to my browser and run localhost, sorry, 8080, so I should see the Jenkins. Okay, so if you have earlier attended the Jenkins session, so we know Jenkins takes little time, and for first time you need to have the admin password, which is temporary part. So if it was running on a normal machine, then you would have gone and search this part. But if you see this, uh, this is on a Windows machine. I'm running this Docker image which is generated from Ubuntu on my Docker Windows machine. So there is no environment. So this environment is inside the container. So each and every container will have slash where and those kind of paths which are separate from each other. This is what the containerization or isolation based on containerized execution is. So I may have a two Jenkins running with different ports, and both have a different where and Jenkins home. So how to access it? So I'll show you this thing. So this is how inside the Docker, using the Docker, you can go inside the container, and inside the container you can find or do or kind of check for the logs. So this is how I'm doing it. So if I just go and this thing, so I'm executing a command on the shell on this particular container. So this is the shell which is I'm executing a command which will do the cat of this particular file, and this file, as you know, contains the password. So it is taking little time because of low configuration machine, but it doesn't take this much of time on production system. So if I just copied this, so this is the password, and and we are ready. So our Jenkins using Dockerized Jenkins is ready to execute. Now we can just do the other configurations which we want to do, correct? Then there are other things which we can also check. If you just want to see the Jenkins log, you can do it. So what we are doing here, we are again executing something on this particular Jenkins master. So what we are doing, we are just doing a tail. So it's basically just keep on printing the Jenkins log on the machine. So it's basically just monitoring logs if anything is wrong or not. So since like uh, okay, so might be path is not correct, so it's not printing it. So uh, another part which is very interesting part is like the life cycle management, or just like for example, you don't want a Jenkins now. What you will do, if it was a virtual machine, then you would have shut it down, correct? Shutting down would have taken, it takes a long time, correct? So but here if you see, I just want Jenkins. I don't want this machine for now, correct? I just want to shut it down. So it will just shut in a very short time, correct? Uh, Now it is down. If I just go and see it, it's not coming. So it's just, and if you just I want to use it now, so what I will do, I will just start it again. So you can start stop containers, and you see it is just in few seconds it's up. So this is like point which we were talking, the use cases, the management, starting stopping is very fast. If you had to do the same thing in VM, it would have taken a long time, because it has to start the OS, and once the OS starts, and it has to start the Jenkins, it has to do the configuration, and all those kind of things takes a long time. So one part is left now. You can remove it. So once you remove it, so this container will get destroyed, and anything inside it would also get destroyed. Like if you have a logs inside it, if you have some configuration inside it, or some temporary files which has created during the execution, that would also be destroyed. So there are certain ways to like have those things still running. Uh, you can you can create volumes, so that whatever logs are saved, generated, they are saved inside the container, and then they are copied outside that config volumes. So in that way, you can have a configuration. You can have your log files generated outside the container. So you can, once you destroy this container, those configuration or log files, they are available. Okay. So if you see just basic commands, docker, ps, so you can see the processes if there are any. Okay, let it execute. Meanwhile, like this is the GUI, so you can always go and see, like this is a picturized GUI based view, correct? This what we were running. You can see that Docker image. So this is what we were running. So here uh, you can stop it, you can restart it, you can delete it, right? Then you can check the logs, stats, so how much memory it took, and what is the CPU utilization as of now. So all those kind of things you can see it. So okay, so so sorry, here this rm command did not work, because before the remove we have to stop it. So if we just do the same thing using here, so see here if you see, system is still running. So it did not actually remove the container. So we can do, we can do the same thing from here. We can stop it. You see the logs. It will stop it. Now it is stopped. Then we can delete this container in this way. So the same thing. If you see here, it was running. So it PS showed all the things. Now if I do the PS again, uh, so since this container has now been destroyed, so there would be no entry if we run the docker ps command. So coming to now, we are back to the end of the webinar. So now we have seen what are the different advantages, use case of dockers, why we should use dockers, and we have seen a small demo how we can use these docker commands, or how we can use container, and how does these commands or things which we saw maps to the use cases which we discussed earlier. So in case if you have any queries, we can go through the Q&A session. Otherwise, we are already 5-10 minutes beyond our scheduled time. So we can close it. So just in case any of you have a question, let me know. Okay, fine. I think there's no question from audience. So thank you for being here. Uh, so see you next time. We will come up with some other webinar which will help in no, discussing or knowing what is the trends in the DevOps across the organizations. Thank you for your time. Bye.